say before we dive into today's stuff, using more than one pair of congruent triangles, before we start this, let me say that this can be a very difficult and confusing lesson sometimes, or assignment. The process is a bit more difficult. I will tell you to separate triangles. I'll emphasize that now. I'll emphasize it during the lesson. And it really helps students that will actually separate them and draw them out. Those students generally are more successful than those that try not to do that. It takes more time to do that, okay, because you've got to redraw the triangle, but it makes it easier. So there's your warning. Please try to separate them. It'll make it easier. Otherwise, it can be a very confusing assignment. Okay? You've got a cool comic back here. I don't know if you guys can read that. But it says, I can't even read it.
I'm so dead.
I'm so dead. Oh, okay. You guys read it. Yeah, go ahead.
I'm so dead. What's wrong? I have to read this 280-page book in 3 days. That's like 70 pages away. No way I'm that. I'm dead. I'm dead. I'm totally dead.
Actually, it's 90. Is that 80?
93.
93 pages a day.
I've noticed you never give me math help when I want it.
Point 3.
That good stuff. Man, that is just funny.
I don't understand.
Come on.
She doesn't give her math help.
Like he's doing the division. That's like 93.33333 pages a day. So never ends. Never ending. It's amazing. All right, probably not that funny to you. I got a good chuckle. So, all right. So you have the work together on page 435. Okay? That means you have to work together. That means you have to find someone to work with. Do your best. You get no more than 5 minutes on it. Hey, this is the work together right here. I'm sorry. There you go. You don't even need a book. That is the work together right there. It's on the back of your warm-up. Okay? 5 minutes. Ready, go. As you progress through it, generally the questions that come up are things like, and maybe... Psst. How's it going? Generally things that come up are things like, maybe, why am I doing this? Or, what in the world, what are they trying to do? Anyone have that feeling as they're going through it? Okay. The reason why I try not to help on this is because sometimes when you get into a proof, especially more complex ones, unless you have a roadmap, you just keep going around in circles. Okay, it's like once you get your license and your friends go, hey, you want to go somewhere? Sure. Where do you want to go? I don't know. Where do you want to go? I don't know. Okay, well, let's go. And then you just go. And where are we going? I don't know. Where are you going? I don't know. You just like driving around, wasting gas. Okay? It's kind of fun to hang out with your friends. However, you have no purpose in what you're doing in terms of driving somewhere. When you are doing a proof, you want to have purpose, a reason why you're doing what you're doing. And as you're looking at this, you three back there, Ethan, I need you to focus. Bethany, I need you to focus. Okay? When you're going through a proof, you really need to make sure you're paying attention to what you're trying to accomplish. Okay, so starting this piece, a lot of you had no idea what you were trying to do other than prove this. And some of you didn't even read that. You just started right here. You're like, okay, A. Hey, that's given. Woohoo! I got it. All right, B. Okay, now remember, as you write the proof, you're going to have to put the statements also. So you need to know what you're trying to do. If you're trying to prove BX is congruent to DX, then based upon what we did yesterday, it would be helpful to probably use corresponding parts, right? Corresponding parts of congruent triangles, which means you would somehow have to prove a triangle congruent that has these parts. Well, these parts right here, this is a part of this small triangle. Okay, so if we're looking at this, it's a part of this triangle. and this is a part of that triangle. And by eye, those look congruent. Everyone with me? So if we could somehow prove these triangles congruent, then we could show that those sides are congruent based on CPCTC. So now you have a purpose. You have a plan. You have why you're doing what you're doing. Now, it still doesn't necessarily tell all this other stuff, because as you're looking through it, CA to CE, you're like, that has nothing. That's not even a part of this triangle. I mean, some of you would maybe start out with vertical angles. Like, dude, I got this. All right, I'm good. I actually have this and this by given. So maybe you go there and then you go there. That's a given, and that's vertical angles. And they actually put the BXA, that's way down here. Okay. The problem is, to prove this triangle congruent, you only have now a side and an angle. And we don't have anything else. So we somehow have to come up with another side or another angle in there. Okay? So, if we're doing that, once you realize you can't do this, then you have to say, well, is there a way to prove maybe this angle congruent to that angle, or that one congruent to that one, or this side congruent, well, that's part of how this side congruent to that side. So you'd have to look at those as parts of other triangles. So when you look at it, you go, well, this angle right here and that angle right there, they're a part of this triangle. Now I've kind of emphasized that so you can see it. And this triangle. Everyone see that? So if I can prove those two triangles congruent, then I can use corresponding with those. Everyone with me? Okay. So that's the process they're doing right here. BAE. Okay. They've started out by coming up with this angle, and I'm highlighting it out here. It's actually that angle. Congruent to that angle because this side was congruent to this side. CA was congruent to CE. So that's by definition of what? Isosceles triangle. Now technically, we could have got really technical and had to actually say that's an isosceles triangle. We know that that's an isosceles triangle because CA is congruent to CE. You could say, oh, go ahead.
You also say that like base angles of isosceles triangles.
Base angles of isosceles triangles are congruent? Yep. Is that what you said?
Yeah.
Yep.
I'd use that versus just definitions.
That would have been fine. That probably would have even been better. Base angles of isosceles triangles are congruent. Okay, then we have AE congruent to AE. That is reflexive. Now, based upon the way we've said this, technically we should actually say EA, right? Because these triangles are flipped around. So A and E in the different triangles are our corresponding parts. How about BA to DE? That's a given? Yep, that's one of our given statements. So we now have that. We have that. And based on side, angle, side. Okay, how many made it that far? Great. Now we have those triangles. Now we can say that this is congruent to that, right? CPCTC. And now that we have an angle and a side, angle, angle, or angle, angle, side. We have the triangles. And then CPCTC. Okay. Questions? I didn't expect everyone to get that whole thing. However, what I did expect is for you to struggle through it and start asking questions like, why in the world are they doing that? Or what am I doing? What's the purpose? Because that's what you're going to be doing on some of these proofs if you don't figure out a plan first. Okay? You will end up doing tons of statements and you'll have all this stuff down. You'll compare to a friend. They're like, what are you doing? Go, I don't know. I just started writing stuff down. Okay? Have a plan. Yeah? Well, it's not necessarily what not to do. I mean, it's a good proof. But it's the process in which you go about it how many of you work backwards through it? Okay, working backwards through it's a good process because you know what the ending is, and you see, oh, I see what they're doing. And that's kind of what I was trying to do with you. Okay, now you don't always know to work backwards, but if you start out what you're trying to prove, and then kind of say, well, that's kind of like we did, that's part of this triangle, so if I could prove this triangle, well, I don't have enough there, so I've got to prove this triangle to get that part of the triangle. Okay, you're working your way backwards. Yeah?
Would it be better to work down in order, or like, because I kind of jumping around proving things?
Well, usually you're not going to be given the statements. So I would say work backwards from your prove point. Okay, now it doesn't mean actually your numbering has to be backwards, but you've got to think, your thought process has to go backwards. Okay? Okay, let's try some of these. First thing I want to do is it would help out if we were able to separate those triangles. So that's example 1. Our assignment today is going to be the example side of the worksheet you picked up, or you got. And I actually have every problem up here for a slide. So we get as far as we get as a class. We do the whole thing together. Fantastic. Okay, it's a tough assignment. My purpose right now, I want you to separate and redraw the triangles. Identify the common angle or side once you get them separated. Okay? Go for it. 1 through 3. Or 1. Okay. As you're looking at 1, 2, 3, okay, when you're looking at them, find the triangle that shares the triangles that are congruent, that look congruent, that share a common side or angle. So yeah, for like number 1, we wouldn't want PQT and RQU because they don't share a common side or angle. However, there are 2 triangles on there that do. Find them and separate them. Hey, there's number 1. Did you get it? Angle S is common.
Oh.
Total O. Check it out, man. We have this triangle right here. And that triangle right there. Redrawn. There we go. Alright. Keep cranking through. We've got 2 and 3. So already, go ahead and share with your neighbor what you got for number 2.
That would be easy. Don't have anything yet. Oh, so.
All right, there is number 2. We've got our SWV, or excuse me, WVU. I want you guys to see that proof down there.
I want to see the proof.
That was a close one. Whew. All right. Questions on that one? All right, I'm going to skip down to number 4. If you guys need help on 3, make sure you ask. I want everyone to take a look at number 4. Number 4 says write a 2-column proof. All right. So on your clean sheet of paper, let's go ahead and write that proof out. Okay, at least get it started, and we'll talk about what we're trying to prove. Let you get your paper out first. Number 4, take a look at what you're trying to prove. Here's how we start this. Take a look at what you're trying to prove. Identify it by highlighting a side. That would be helpful. And then come up with what part of the triangles, or which triangles those sides are a part of. Okay? And those are the triangles we should try to figure congruent to begin with. So, highlight it. Come up with a plan. Tell your neighbor your plan. Okay, here we go.
Side,
JG to HF, or HF here. Okay. That's what we're trying to figure out. We're trying to prove. Anyone have a plan? Grace, you got a plan. What do you got?
So, since you're gonna need, so since there's a right angle and one of the legs is congruent, you need to find the hypotenuse to be congruent, which is, you can do that by reflexive.
Okay, so what are you trying to prove right now?
The
Okay, which triangles were you just trying to prove congruent?
A, F, J, G, and G, H, F.
Okay, so G, H, F, congruent to F, J, G?
Yeah.
Okay. How many had that plan? You can prove this triangle right here congruent to that triangle right there. Now I will tell you it's helpful if you can just say, hey, I want this triangle. Okay? JFG. Doesn't have to be beautiful, just enough that you can mark it down, and I want this triangle. And obviously did not do a good job of drawing that one. I didn't give myself enough room. But HGF. Okay, that's what I have right now. I have this is congruent to that. That right angle is congruent to that right angle. I've separated the triangle. And now, Grace, you said that this is going to be congruent to this, or in that picture, it's that and that. How come?
Because of reflexive.
Reflexive. Everyone agree there? Okay, so we could actually go through our proof, because now that gives us, how are these triangles congruent? HL. Okay, so we have reflexive, and then we have HL, and then what's the last reason we're going to use? CPCTC. CPCTC. Okay, we've got it. Now we just have to write up our formal proof for it. Say, give it a go there. Finish up if you haven't done so. If you have, you can look at number 5. Two really good questions. First, what side do they have? The reflexive is the side they have in common. That's this side right here. Okay, there and there. And the second question, it would be FG to GF, right? Because G corresponds to F and F corresponds to G. Okay, the triangles aren't perfect mirrors of each other. So you've got to switch the corresponding parts there. Okay, good question. Okay, let's see how you did. There is our proof. Okay. Yeah.
So for the reflexive, would you do FG?
Yeah,
Is
this should
FG
be-
or GF?
This should be FG to GF.
So it would be FG to GF.
Yeah,
Making
that's
sure.
that's backwards. Yes, good call. Other questions? Okay, good. Let's take a look at number 5. All right, number 5. Given triangle NMP congruent to triangle NOL, NM is congruent to no, prove angle L to angle P. All right, look for overlapping triangles, work your way backwards, okay? Figure out maybe what they share, separate those triangles, come up with a plan of attack. Go for it. As you are able to use reflexive property on sides and angles, okay? Okay, anyone want to give me their plan? Cameron?
Triangle MNP and ONL, or angle side angle.
So prove the triangle MNP congruent to ONL by angle side angle. Okay, so if we can do that, then we can use CPCTC.
Wait, you can't see all of that?
Oh, sorry. So that's our plan, CPCTC. So there's our plan. Now, can we actually do that with what they give us? What's the other reason we're going to need? Yeah, or Rory?
That angle N is congruent to angle N reflexive.
Okay, so we'll need to actually state angle N congruent to angle N by reflexive. Okay, so that is our plan. Now we've got to put it in a formal proof. If we separate those two triangles, we've got that guy there and that guy there. This is N, O, L, and this is N, M, P. Okay, congruent by reflexive. So we need two markings. We have congruent given, and we have given. So that's going to be angle side angle. Nice job. Yeah. Okay. Questions on that plan? How many are able to pick it out? Okay. So our formal proof on it should end up being using those pieces. There we've got it. Okay. Now you could just say angle in to angle in here, reflexive, because that's the only angle coming from that. But that'll be okay. Okay. They get a little more complex as we go. Number 6 is a bit more difficult. Okay. Take a look at 6. Now you may not be quite done with 5 yet, but take a look at 6. Bethany, do you have a question?
Yeah, on 6.
Okay.
I don't see how, like, it's hard, like, you can use vertical angles to stuff.
You could use some vertical angles. Here we're trying to prove that triangle STR congruent to QTP.
Okay, I read it.
It looks a little more complex than it actually is. Okay, mark out your given pieces, separate your triangles. So really, beside your given, what else do you need? What's that? Yeah, just vertical angles, right? And if I'm going with this triangle congruent to that one, as complex as the figure looks, we have side, angle, and angle. Angle, angle, side if we state vertical angles. Right? So really, we just need our given, our vertical angles, and then we have angle, angle, side. Those are our statement or our reasons there. Not too bad on that one, even though the picture looks tougher. Okay, your assignment is to finish example side. Not too much. Okay? All right, very good.